Hi there, and welcome to the Science Lullaby. I'm glad you're here. Maybe you've just turned off the lights. Maybe you're lying in bed, listening in the quiet, ready to drift off while your mind keeps wandering. Wherever you are, take a slow, deep breath. Let your shoulders relax. Let your thoughts settle like sand sinking slowly to the bottom of the sea. Tonight, we're leaving the familiar world behind, the noise of the surface, the warmth of sunlight, and diving into a realm very few have ever seen. Beneath the calm blue waves, deeper than any diver can reach, lies a hidden universe, dark, silent, and alive. Down there, pressure could crush steel, light cannot survive, and yet, somehow, life finds a way. Creatures glow with their own light. Mountains rise from the ocean floor, and valleys stretch deeper than the tallest peaks on land. For centuries, humans have dreamed of space, of galaxies far away, but the greatest mystery may have always been right here, beneath us, in the deep blue unknown. So, as you close your eyes and let the day fade away, join me on a quiet descent past the waves, past the twilight, into the hidden heart of our planet. Because tonight, we're going to explore what lies beneath the ocean floor. Take another breath. Listen to the quiet hum of the world around you. Now imagine floating high above the earth, looking down from space. What you'd see is not a green planet, but a blue one. More than 70% of Earth's surface is covered by ocean. From orbit, it looks like a shimmering sapphire wrapped in white clouds. But what's most astonishing is not how vast it is, it's how little of it we've truly seen. If you gathered every ship that has ever sailed, every diver who has ever plunged beneath the waves, and every robot that has mapped the deep, they would still have explored less than 5% of the seafloor. The rest remains untouched, dark, cold, silent. An entire world beneath our own, stretching for thousands of kilometers in every direction. We know more about the surface of Mars than the bottom of our own oceans. And that's not poetic exaggeration, it's scientific fact. When you think about it, it's strange. We've crossed the skies, we've split the atom, we've sent probes beyond the edge of our solar system, but we still don't fully understand what lies beneath the blue horizon. That's because the ocean hides its secrets well. Sunlight fades completely at about 200 meters below the surface. Beyond that, light disappears, color vanishes, and the world turns to shades of black and blue. At 1,000 meters, the pressure is 100 times greater than at sea level. At 10,000 meters, the depth of the Mariana Trench, the pressure is enough to crush steel like paper. It's a place where human lungs could never breathe, where sound travels faster and where time seems to slow, suspended in silence. And yet, somehow, life endures. Scientists call our oceans the planet's lungs. They generate over half of the oxygen we breathe. Tiny organisms, phytoplankton, drift near the surface, absorbing sunlight and releasing oxygen with every flicker of life. They are so small you could fit thousands in a single drop of water, and yet, together, they sustain the entire biosphere. Beneath them, vast currents circulate like arteries, the global ocean conveyor belt, carrying warmth, nutrients, and energy across the world. This invisible motion regulates climate, seasons, and even the air we feel on our skin. In every sense, the ocean is alive, breathing, moving, thinking, a single interconnected system that wraps the planet in blue. But if the ocean is the Earth's body, then its floor is the mind, deep, quiet, and largely unknown. For centuries, people believed the seafloor was flat and lifeless, a silent grave of silt and stone. That belief shattered in 1872 when a British expedition named HMS Challenger set sail to study the depths. They dropped weighted ropes and collected samples from the bottom of the ocean. And what they found changed everything. The ocean floor was not dead. It was teeming with life. Strange worms, sponges, starfish, and organisms no one had ever seen before. Some lived in total darkness, miles below the surface, surviving on falling fragments of organic matter, the so-called marine snow. For the first time, humanity realized the deep sea was not an empty void. It was a universe of its own. The Challenger expedition became the birth of modern oceanography. It proved that life adapts in ways we could barely imagine. Since then, each generation of explorers has descended deeper, and each time they've discovered something new. Yet, for all our progress, sonar mapping, submersibles, satellites, most of the ocean floor remains unmapped, its mountains unnamed, its valleys unseen. It is the last great wilderness of Earth, a place where even the most advanced technology feels small. When you listen to the ocean from above, it sounds calm, waves rolling, distant gulls, the rhythm of tides. But if you could hear it from below, you'd find an entirely different world of sound. Whales call across thousands of miles. Earthquakes echo through the crust. Hydrothermal vents hiss with volcanic breath. And somewhere in the dark, the faint crackle of tiny shrimp forms what scientists call the sound of the seafloor. The ocean is never truly silent. It's just that most of its music is too deep for us to hear. It's easy to forget how dependent we are on this unseen world. Every second breath we take comes from it. Every rainfall, every gust of wind is shaped by the ocean's invisible rhythms. And yet, we treat it like a stranger, something distant, something separate. But the truth is, there is no boundary between us and the sea. The salt in our blood, the water in our cells, the cycles that keep us alive, all began there. In a way, we never really left the ocean. We just learned to carry a part of it inside us. As you listen, imagine yourself floating at the surface, looking down into that endless blue. You can't see what's below, but you can feel it. That quiet pull of curiosity, that sense that something ancient and alive is waiting in the dark. Because beneath the waves lies a story older than life itself, a story written in pressure, in silence, and in light that never reaches its destination. And to understand it, we have to go deeper. In the next part, we'll leave the surface behind completely and discover why the deep ocean remains one of the last unexplored frontiers on Earth. Take a moment and imagine yourself sinking slowly beneath the surface. At first, light dances all around you, turquoise and gold rippling in motion. But with every meter you descend, the colors fade. Blue becomes indigo, indigo turns to black, and soon you are surrounded by nothing but darkness. This is where exploration becomes difficult, not because of curiosity, but because the ocean does not easily reveal its secrets, the barriers of depth. Every 10 meters you descend adds one additional atmosphere of pressure. That means by the time you reach just 1,000 meters, you're experiencing 100 times the weight of the air at sea level. At the very bottom of the Mariana Trench, nearly 11,000 meters deep, the pressure reaches 1,100 times greater than the surface. To survive there, any machine must be built like a fortress. Every bolt, every seal, every window must resist crushing force. Even a small crack could mean instant collapse. That's why exploring the deep sea is as complex as sending a spacecraft into orbit. The difference is that space is empty. The deep ocean presses in from every direction. The darkness barrier. After a few hundred meters, sunlight disappears completely. Below that, there is only blackness, a kind of darkness so absolute that the human eye can never adjust. Cameras struggle to capture it. Light from submersibles reflects off tiny particles, making it feel as if you're floating through a starfield made of dust. It's haunting and beautiful, but this darkness makes traditional exploration nearly impossible. We can't see without light, and in the deep sea, every beam we bring fades within a few meters. To the creatures living there, our lights are blinding intrusions. To us, their world is invisible. So we've learned to listen instead, to send sound waves down and read the echoes that come back. That's how we map the ocean floor today, not by seeing it, but by feeling it through sound. The technology barrier. For most of history, we simply didn't have the tools. Beneath them, vast currents circulate like arteries, the global ocean conveyor belt, carrying warmth, nutrients, and energy across the world. This invisible motion regulates climate, seasons, and even the air we feel on our skin. In every sense, the ocean is alive, breathing, moving, thinking, a single interconnected system that wraps the planet in blue. But if the ocean is the Earth's body, then its floor is the mind, deep, quiet, and largely unknown. For centuries, people believed the seafloor was flat and lifeless, a silent grave of silt and stone. That belief shattered in 1872 when a British expedition named HMS Challenger set sail to study the depths. Most exploration now relies on ROVs, remotely operated vehicles, and AUVs, autonomous underwater drones. They send back fragments, short video clips, sonar images, occasional samples. It's like trying to understand an entire planet by looking through a keyhole. The cost of curiosity. Exploring the deep sea is expensive. Each expedition costs millions of dollars, and the equipment must survive crushing pressure, freezing temperatures, and total darkness. Unlike space missions that capture global headlines, deep-sea exploration rarely gets the same attention. It happens in silence, funded by a handful of scientists, engineers, and dreamers who believe that Earth's greatest mystery still lies beneath. But slowly, technology is catching up. Today's high-resolution sonar can map the sea floor in astonishing detail. New materials like titanium alloys and synthetic foams allow vessels to resist incredible pressure, and artificial intelligence is helping underwater drones make decisions in real time, deciding where to go, what to study, and how to survive the unpredictable environment of the abyss. Every year, we see further, but still, the ocean keeps most of its secrets. The unknown percentage. According to NOAA, more than 80% of our ocean remains completely unmapped and unobserved. We don't know what landscapes lie there. Mountains, volcanoes, valleys, and plains, nor do we fully understand the ecosystems that depend on them. In 2023, an expedition discovered over hundreds of new species on a single deep ridge off the Pacific coast. Before that dive, scientists had no idea those organisms even existed. That's how vast the unknown still is. A single journey can rewrite what we thought we knew about life. And it's not just biology. The ocean floor records the Earth's history, from continental drift to mass extinctions. Buried sediments hold clues to the climate of millions of years past. To explore it is to read the diary of the planet itself. A mirror of space. Ironically, the deep ocean and outer space are more alike than different. Both are silent, vast, and filled with the unknown. Both require machines to survive. And both force us to confront the limits of human perception. Astronauts often describe looking down on Earth as humbling, but oceanographers say the same about looking up from the dark. In the abyss, you realize how fragile the surface world really is, how small we are compared to the machinery of nature. And maybe that's why exploring the ocean feels so deeply human, because what we're truly exploring isn't just the sea, it's our own capacity for wonder. The ocean hides its mysteries beneath pressure, darkness, and distance. But the deeper truth is that the unknown has always called to us. Each dive, each expedition is humanity whispering to the void, asking, what else is out there? In a way, we never really left the ocean. We just learned to carry a part of it inside us. Every 10 meters adds one more atmosphere of weight, one more invisible hand pressing from every direction. At 200 meters, a human body would feel like it's carrying an elephant on its chest. At 1,000 meters, it would feel like a skyscraper. And yet, this immense pressure doesn't destroy everything. It shapes life. It defines who can survive here and who cannot. The physics of depth. Let's imagine a simple soda can. If you took it down to a depth of 1,000 meters, it would flatten instantly, its walls imploding with a sharp, metallic sigh. That's 100 times the pressure of the air around us right now. And at the bottom of the Mariana Trench, the force is over 16,000 pounds per square inch, the weight of 50 jumbo jets pressing on a single human body. But life somehow adapts. Creatures here don't resist the pressure. They become part of it. Their bodies have no air pockets, no rigid bones that could snap. Instead, they're soft, flexible, and balanced with the water around them. Their survival depends on harmony, not strength. The human limit. For us, pressure has always been the barrier between curiosity and danger. In 1960, two explorers, Jacques Piccard and Don Walsh, set out to challenge that barrier. They entered a small, round vessel named Trieste. But here, In the literal pressure of the deep, that metaphor becomes real. Every sound, every movement feels amplified. You can hear your heartbeat. You can feel the immense stillness pressing on your thoughts. Explorers describe it as humbling, a silence that feels almost sacred. Down here, the ocean teaches us that pressure isn't always an enemy. Sometimes it's what shapes us. Sometimes it's what makes us capable of enduring. Life's gentle resistance. Deep sea creatures are living lessons in adaptation. They don't resist their environment, they harmonize with it. Their bodies adjust their internal chemistry to match the surrounding water. Their enzymes are specially built to function under pressure. And their cells are filled with substances that prevent them from collapsing. In other words, they don't fight the ocean, they become one with it. That idea of balance instead of struggle is something both beautiful and profoundly human. Even in the darkest, most crushing places, life doesn't give up. It learns to breathe differently. The deep philosophy of pressure. When you think about it, the ocean is the perfect metaphor for existence. We all live under some kind of pressure, the weight of expectations, of time, of dreams we haven't yet reached. And like the creatures of the deep, we survive not by resisting, but by learning to move with the weight, not against it. Down here, in the heart of the abyss, there's no sunlight, no noise, no rush, just patience, just the slow rhythm of the earth breathing underwater. In the next part, we'll explore the vast plain at the bottom of the world, the silent, endless landscape that forms the true floor of our planet. This is the abyssal plain. We've reached the bottom, or at least what feels like the bottom. Here, beneath nearly 4,000 meters of water, lies one of the most mysterious landscapes on Earth, a world so vast and silent it stretches across more than half the planet's surface. This is the abyssal plain, the true floor of our blue world. If you could stand here, you would see no light, no color, no horizon. Only the slow drift of tiny particles, flakes of organic matter falling gently from above. Scientists call it marine snow, the remains of life from the upper ocean, slowly sinking to feed the deep. It's a place where time seems to stop, a place where the earth itself hums in the background, a silent landscape. The abyssal plain is a vast desert beneath the sea, but unlike deserts on land, this one is alive. It's covered in a thin layer of soft sediment, mud, silt, and the remains of ancient organisms. Beneath that lies solid basalt, rock formed from the Earth's crust millions of years ago, the temperature here stays close to freezing, and the water barely moves. In the abyss, life is patient. It waits. It endures. The geography of the abyss. From afar, the abyssal plain might seem flat, but it's not. Beneath the surface of that endless mud lie hidden mountain ranges, deep valleys, and volcanic ridges that span entire continents. These mid-ocean ridges are the longest mountain chains on Earth, stretching more than 60,000 kilometers around the planet. It's here that new crust is born, magma rising from the mantle, forming new seafloor that slowly spreads outward. In a way, the ocean floor is constantly breathing, creating and recycling itself over millions of years. Every ridge, every plain, every trench tells a part of that slow geological heartbeat. The sound of stillness. If you could listen to the abyssal plain, you would hear almost nothing. No wind, no rain, no voices. Only the occasional whisper of a current or the faint, distant crack of an earthquake echoing through rock. Sound travels faster here, about 1,500 meters per second, so even a distant tremor can roll across the seafloor like a ghostly thunder. Scientists sometimes lower special microphones called hydrophones to record these underwater echoes. They've captured the low rumble of shifting tectonic plates, the clicks of deep-sea shrimp, and the long, haunting calls of blue whales traveling through the dark. It's a strange paradox, a place so silent, yet filled with the quiet sounds of the earth itself. The rhythm of the deep. Everything here moves slowly. Currents drift like thoughts. Particles fall like snow. And life unfolds on a time scale beyond human imagination. A single grain of sediment may take hundreds of years to settle. A coral may grow only a few millimeters in a decade. Creatures here don't rush. They conserve, adapt, survive. The deep sea is the planet's great equalizer, a realm untouched by seasons or storms. It changes not in days or months, but in centuries. In a world driven by speed, the abyssal plain reminds us that slowness can be sacred. Life without light. Without sunlight, the rules of life change. Photosynthesis, the process that fuels most of the surface world, doesn't work here. So the deep relies on something else entirely: chemosynthesis. At hydrothermal vents scattered across the seafloor, bacteria convert chemicals like hydrogen sulfide into energy. From that invisible spark, entire ecosystems arise. Crabs, worms, shrimp, and fish that depend on no sunlight at all. It's proof that life can emerge anywhere energy flows, even in the coldest, darkest corners of existence. Some scientists believe this might also explain how life began on Earth and how it could exist elsewhere, on moons like Europa or Enceladus. The deep sea, in its stillness, might be a reflection of life across the universe. The hidden energy below. Beneath the abyssal plain lies the lithosphere, the rigid crust of our planet. It holds immense heat, and from time to time, that heat breaks through. Volcanic vents open briefly, releasing plumes of minerals that rise like smoke. Around these vents, new life always appears. It's as if the planet is breathing, exhaling warmth into its coldest chamber. The cycle is endless: creation, decay, rebirth, a quiet pulse beneath the ocean floor. Reflections in the dark. If you were to look around now, you'd see nothing familiar, no landmarks, no sky. And yet, this emptiness feels strangely peaceful. The abyssal plain isn't just a place, it's an idea, a reminder that even in stillness, there is movement. Even in silence, there is life. Down here, the boundaries blur between science and philosophy. Because to understand this place, you can't just measure it, you have to feel it. It's the hum of the earth in its purest form, the sound of patience, the art of existing quietly. In the next part, we'll discover something extraordinary, the places where the ocean floor comes alive with heat and fire. These are the hydrothermal vents, where life begins without sunlight. Imagine the ocean floor we just visited, silent, cold, motionless. Now, imagine a sudden flicker of light, not sunlight, but something else. A glow rising from the cracks of the earth itself. Here, in the darkness, the seafloor breathes fire. Superheated water bursts upward through vents, carrying clouds of minerals and chemicals from deep within the planet. These are hydrothermal vents, and they are among the most extraordinary discoveries in all of science. A discovery that changed everything. The year was 1977. A research vessel called Nor sailed to the Galapagos Rift, a crack in the seafloor near Ecuador, where scientists expected to find nothing but lifeless rock. At the very bottom of the Mariana Trench, nearly 11,000 meters deep, the pressure reaches 1,100 times greater than the surface. To survive there, any machine must be built like a fortress. Every bolt, every seal, every window must resist crushing force. Even a small crack could mean instant collapse. That's why exploring the deep sea is as complex as sending a spacecraft into orbit. The difference is that space is empty. The deep ocean presses in from every direction. The darkness barrier. After a few hundred meters, sunlight disappears completely. Below that, there is only blackness, a kind of darkness so absolute that the human eye can never adjust. Cameras struggle to capture it. Instead, the energy came from the earth itself. The key was chemistry. Microbes living inside the vents used hydrogen sulfide, a gas toxic to most surface life, and transformed it into energy through a process called chemosynthesis. It was the first proof that life could exist without sunlight. These microbes became the foundation of an entire ecosystem, one that didn't rely on photosynthesis, but on the raw power of the planet's interior. The idea was revolutionary. Life didn't need the sun. It needed only energy and the ability to adapt. The architects of survival. The tube worms were perhaps the strangest discovery. They had no mouths, no stomachs, no digestive systems. Instead, they hosted bacteria inside their bodies, a perfect symbiosis between animal and microbe. The worms provided shelter. The bacteria provided food. In this partnership, we saw life's creativity at its finest. In the harshest, most unlikely environment, nature found a way to cooperate instead of compete. Around them, fish and crustaceans gathered, each relying indirectly on the microbes at the base of the chain. Like a forest growing from heat instead of light, the vent ecosystems thrived, lush, alien, and beautiful, the alchemy of the deep. Inside each vent, the temperature can exceed 400 degrees Celsius, 750 Fahrenheit. But because of the immense pressure at these depths, the water doesn't boil. It becomes a superheated fluid, rich in iron, manganese, and sulfur compounds. As this fluid bursts into the cold ocean water, minerals solidify and form towering structures, chimneys called black smokers and white smokers. They look like underwater volcanoes, releasing dark plumes that rise like smoke from an invisible fire. Over time, these chimneys can grow several meters tall, becoming homes for countless creatures. The ocean floor, once barren, transforms into a city of lightless life, built not on photosynthesis, but on pure chemistry. A glimpse into the past. Some scientists believe these vents hold the key to our own beginnings. Billions of years ago, before plants, animals, or sunlight-based ecosystems, Earth may have been covered by oceans filled with volcanic activity. In that environment, hydrothermal vents could have provided the perfect cradle for life, a steady source of energy, protection from radiation, and a complex mix of minerals needed for chemistry to begin. Perhaps, they suggest, the first cells formed here, in the warmth of the deep, surrounded by iron and sulfur, bathed in mineral-rich water. If that's true, then every living thing, every tree, every animal, every human can trace its origins back to a place where fire met water in the dark. The echoes of other worlds. What's even more fascinating is how these vents mirror distant places beyond Earth. On moons like Europa around Jupiter and Enceladus around Saturn, scientists have detected vast subsurface oceans. They are sealed beneath layers of ice, but may hide hydrothermal activity at their rocky cores. If life could begin in Earth's dark oceans, then perhaps it could exist there too, not under starlight, but in the same chemical glow we see here. Every time we study hydrothermal vents, we're not just looking at our own planet. We're looking at the blueprint of life across the cosmos. The balance of extremes. Despite their heat and violence, these vent ecosystems are fragile. A small shift in pressure or chemistry can destroy them completely. Some vents stop flowing after a few years, and the life around them vanishes as quickly as it appeared. Others last for centuries, becoming permanent fixtures in the deep. It's a reminder that even in the most resilient systems, change is constant. Nothing lasts forever, not even the mountains of the seafloor. The fire that sustains the cold. There's something profoundly poetic about this balance. The coldest, darkest part of Earth depends on fire from within to stay alive. It's as if the planet itself breathes warmth into its own depths. Life, in all its forms, is born from contrast, light and dark, heat and cold, silence and sound. The ocean, too, finds its heartbeat in that contrast. Here, far below the surface, we are reminded that creation and destruction are not opposites, they are partners. In the next part, we'll meet the inhabitants of this strange world, creatures that glow, hunt, and communicate with light itself. They are the stars of the deep, the creatures of darkness. Close your eyes for a moment. Imagine drifting through a world without light. No sun, no moon, no reflection. Only endless, silent darkness pressing from every side. And then a flicker, a pulse of blue light glowing faintly in the black. Then another and another. The ocean's darkness begins to shimmer with sparks like a night sky turned upside down. Every 10 meters adds one more atmosphere of weight, one more invisible hand pressing from every direction. At 200 meters, a human body would feel like it's carrying an elephant on its chest. At 1,000 meters, it would feel like a skyscraper, And yet, this immense pressure doesn't destroy everything. It shapes life. It defines who can survive here and who cannot. The physics of depth. Let's imagine a simple soda can. If you took it down to a depth of 1,000 meters, it would flatten instantly, its walls imploding with a sharp, metallic sigh. That's 100 times the pressure of the air around us right now. When luciferin reacts with oxygen, it releases energy in the form of light. Each species creates its own color, blue, green, or even red, depending on the depth and purpose of the glow. Blue is the most common because it travels furthest in water. At these depths, red light disappears completely, so creatures that glow red are effectively invisible, able to sneak through the darkness unseen. Nature, once again, proves its genius. The hunters of light. One of the deep sea's most famous residents is the anglerfish, a creature both terrifying and fascinating. It drifts silently in the dark, its body nearly invisible. But from its forehead extends a small, glowing lure, a piece of flesh that shines like a tiny lantern. Smaller fish, drawn to the light, swim closer, thinking they've found something gentle. They never realize that the light is a trap until it's too late. In a single movement, the anglerfish strikes, swallowing its prey whole. This is nature at its most efficient, energy conserved, movement minimal, light used as both camouflage and weapon. And yet, there is something oddly beautiful in its design, a perfect predator built for silence. The architects of illusion. Other creatures use light not to attack, but to disappear. Hatchetfish, for example, have small organs on their bellies called photophores, tiny windows that emit just enough light to match the faint glow coming from above. To predators below, they vanish completely, blending into the shimmer of the surface light. It's called counter-illumination, and it's one of the ocean's most elegant tricks. Some shrimp release clouds of glowing chemicals to distract attackers. Others flash bright lights in rhythm, communicating with potential mates through pulses of color. Down here, language is made of light. The deepest lanterns. At greater depths, where even bioluminescence struggles to travel, life still finds a way to glow. There are vampire squids, drifting gently with arms outstretched, their bodies glowing red like embers. When threatened, they turn themselves inside out, displaying their glowing underside to startle predators. Lanternfish move in vast schools, their bodies dotted with tiny lights along the sides. Together, They create underwater constellations, patterns that shift and move like galaxies in slow motion. And then there are the atoll jellyfish, perhaps the most mesmerizing of all. When attacked, they burst into spirals of electric blue, a living alarm system that calls predators of predators, a desperate cry in the dark. Every light down here has meaning. Every flicker tells a story of survival. Why life glows. Scientists believe that bioluminescence evolved independently at least 40 different times in the history of life. But here, in the literal pressure of the deep, that metaphor becomes real. Every sound, every movement feels amplified. You can hear your heartbeat. You can feel the immense stillness pressing on your thoughts. Explorers describe it as humbling, a silence that feels almost sacred. Down here, the ocean teaches us that pressure isn't always an enemy. Sometimes it's what shapes us. Sometimes it's what makes us capable of enduring. Life's gentle resistance. Deep sea creatures are living lessons in adaptation. They don't resist their environment, they harmonize with it. Their bodies adjust their internal chemistry to match the surrounding water. Their enzymes are specially built to function under pressure. And their cells are filled with substances that prevent them from collapsing. In other words, they don't fight the ocean, they become one with it. That idea of balance instead of struggle is something both beautiful and profoundly human. Even in the darkest, most crushing places, life doesn't give up. It learns to breathe differently. The deep philosophy of pressure. When you think about it, the ocean is the perfect metaphor for existence. We all live under some kind of pressure, the weight of expectations, of time, of dreams we haven't yet reached. And like the creatures of the deep, we survive not by resisting, but by learning to move with the weight, not against it. In the next part, we'll meet the giants of the deep, colossal creatures that move slowly through the darkness, silent, ancient, and built to survive eternity. These are the deep sea giants. The deeper you go, the larger life seems to grow. Down here, in the still, black water, size becomes its own kind of survival. This is the realm of the giants, creatures so immense and so old that they feel more like legends than reality. The mystery of deep sea giantism. In the abyss, many animals are far larger than their relatives near the surface. This phenomenon is called deep sea gigantism, and it's one of the ocean's strangest mysteries. No one knows exactly why it happens. but scientists believe it's a response to cold, pressure, and scarcity. In a world where food is rare, a large body can store energy longer. In freezing water, slower metabolisms mean longer lives. And in the absence of predators, there's no reason to stay small. So the deeper you go, the more colossal and ancient life becomes. The colossal squid. Let's begin with the most iconic of them all, the colossal squid. Not to be confused with its cousin, the giant squid, this creature is even larger and far more elusive. It can grow over 14 meters long, longer than a school bus, and its eyes are the size of dinner plates. In fact, they're the largest eyes of any animal on Earth. Each eye is designed to detect the faintest shimmer, the glow of bioluminescent prey, or the silhouette of a passing whale. Its arms are lined with hooks instead of suckers, each one rotating like a small blade. It hunts in silence, using bursts of speed to capture prey in total darkness. For centuries, sailors told stories of sea monsters pulling ships under. Now we know those myths were born from truth. The colossal squid is real, and it still lives in the black water beneath the Antarctic. The Greenland shark. Then there's the Greenland shark, a creature that redefines the concept of time itself. It swims slowly through the icy waters of the North Atlantic, moving with the patience of a drifting glacier. Its body can grow up to 7 meters long, but its most astonishing feature isn't its size, it's its age. Scientists have discovered that the Greenland shark can live for more than 400 years. That means some of them were alive before the invention of the telescope, before Newton, before electricity. They grow just a few centimeters each year, their hearts beating only once every 10 seconds. In their stillness lies endurance, a reminder that survival isn't always about speed, but about balance. The giant isopod. On the seafloor, another giant creeps slowly. The giant isopod, a distant relative of the pill bug you might find under a rock. Except this one is the size of a small dog. It scuttles across the mud, its pale shell gleaming under the faint light of submersibles. It can go months without food, waiting patiently for a fallen fish or whale carcass to drift down. When it finally feeds, it gorges itself until it can barely move, then returns to stillness for another long wait. It's an ancient design, almost unchanged for millions of years. A creature built for endurance, not evolution. The Dumbo octopus. Not all giants are fearsome. Some, like the Dumbo octopus, are delicate and graceful. Named for its ear-like fins that resemble the cartoon elephant, it moves by slowly flapping through the water, its skin glowing softly in the light of the submersible. It lives deeper than any other known octopus, over 7,000 meters below the surface. At that depth, it floats in a slow dance, feeding on tiny crustaceans drifting through the dark. There's something deeply calming about it, a reminder that beauty doesn't need sunlight to exist. The whale fall giants. Even in death, giants shape the deep. When a whale dies and sinks to the bottom of the ocean, its body becomes a feast that can last for decades. Scientists call this phenomenon a whale fall, and it's one of the most powerful symbols of renewal in nature. So the deep relies on something else entirely: chemosynthesis. At hydrothermal vents scattered across the seafloor, bacteria convert chemicals like hydrogen sulfide into energy. From that invisible spark, entire ecosystems arise: crabs, worms, shrimp, and fish that depend on no sunlight at all. It's proof that life can emerge anywhere energy flows, even in the coldest, darkest corners of existence. Some scientists believe this might also explain how life began on Earth and how it could exist elsewhere, on moons like Europa or Enceladus. The deep sea, in its stillness, might be a reflection of life across the universe. The hidden energy below. Beneath the abyssal plain lies the lithosphere, the rigid crust of our planet. It holds immense heat, and from time to time, that heat breaks through. Volcanic vents open briefly, releasing plumes of minerals that rise like smoke. Around these vents, new life always appears. It's as if the planet is breathing, exhaling warmth into its coldest chamber. The cycle is endless: creation, decay, rebirth, a quiet pulse beneath the ocean floor. Reflections in the dark. If you were to look around now, you'd see nothing familiar: no landmarks, no sky. And yet, this emptiness feels strangely peaceful. The abyssal plain isn't just a place, it's an idea, a reminder that even in stillness there is movement, even in silence there is life. Down here, the boundaries blur between science and philosophy. They are reminders that power doesn't always roar. Sometimes it drifts quietly through the dark, content with its own existence. In their stillness, we can glimpse something of the Earth's memory, a patience older than humankind, older than light. In the next part, we'll rise slightly from the ocean floor into the twilight, where light fades but never fully disappears. It's a world between two worlds, the mysterious Twilight Zone. The Twilight Zone, Mesopelagic realm. We're rising now, leaving behind the silent plains of the abyss and entering a place caught between two worlds. Above us, sunlight still shimmers faintly. Below us, darkness waits, patient and endless. This is the Twilight Zone, a band of ocean that stretches from 200 to 1,000 meters deep. It's the last place where light still lingers, but here, light is fragile. It bends, scatters, fades, until it becomes something softer, almost dreamlike, a world between worlds. The Twilight Zone is unlike anywhere else on Earth. It's not quite day, not quite night. It's a realm where colors dissolve into shades of blue, and life learns to live with just enough light to survive. Here, fish shimmer like silver mirrors, their scales reflecting what little light remains. Transparent jellyfish drift like glass ornaments, and clouds of plankton pulse in slow rhythm, feeding on the last traces of sunlight from above. It feels peaceful, but it's not empty. In fact, it's one of the most active ecosystems on the planet, the Great Vertical Migration. Every night, billions of creatures rise from the Twilight Zone toward the surface. Tiny shrimp, lanternfish, krill, and squid. They travel hundreds of meters upward under the cover of darkness, feeding on microscopic plants near the surface. Then, before sunrise, they sink back down into the safety of the dark. This massive movement is called the vertical migration, and it's the largest migration on Earth, not of herds, not of birds, but of drifting, glowing creatures. It happens every single night, silently, all across the planet. As we sleep, the ocean breathes. The ocean's pulse. This daily rise and fall shapes the entire planet's biology. Each migrating creature carries nutrients and carbon with it, a slow, rhythmic exchange between surface and depth. It's like the ocean's heartbeat. When they rise, they feed. When they sink, they return what they've taken. Through this endless rhythm, the Twilight Zone helps regulate the Earth's climate, capturing carbon dioxide and locking it away in the deep. It's an invisible system of balance, keeping the world alive while we dream. Creatures of the half-light. The Twilight Zone is home to some of the most otherworldly beings on the planet. There are lanternfish, small and delicate, whose bodies sparkle with tiny dots of light. They are the most abundant vertebrates on Earth. Trillions of them, drifting like starlight beneath the waves. Hatchetfish flash bursts of light from their bellies, perfectly matching the dim glow of the surface above, vanishing into their surroundings like living ghosts. Bristlemouths, tiny fish with glowing mouths, open and close their jaws in the dark, their light patterns flickering like underwater Morse code. These creatures are fragile, but together they form the foundation of an entire world. Predators of the dim blue. But not all the inhabitants here are small. Larger predators, swordfish, squid, and even sharks, descend into the twilight zone to hunt. They follow the migrating swarms, gliding through the dim water like shadows. Their eyes are adapted to darkness, their bodies streamlined for long, silent pursuit. In this world, light and shadow are weapons. A single flash of movement can mean the difference between life and death. Everything in the twilight zone is about balance. Just enough speed, just enough patience, just enough light to survive. The edge of vision. For us, the twilight zone marks the limit of sight. Sunlight fades completely around 1,000 meters down, and beyond that, no human eye has ever seen unaided. But for the creatures that live here, this boundary is not an end, it's home. They don't need bright light or color. They need only shadow, contrast, and the faintest whisper of illumination to find their way. Their eyes are enormous, their pupils wide. They see what we cannot. Tiny movements, faint glimmers, the language of the dim. The human connection. There's something poetic about this layer of the sea. It mirrors the part of us that lives between knowing and not knowing, between wakefulness and dream. Just as our minds drift into the half-light of sleep, the ocean moves between day and night, breathing in and out, balancing the world in silence. We often look to the stars for mystery, but maybe the real wonder lies here, in this gentle band of blue, where the ocean keeps its quiet secrets. The silent architects of balance. Scientists are only beginning to understand how vital the twilight zone is to life on Earth. If it were to disappear, so would the planet's carbon balance. Without these migrating creatures, carbon would remain trapped near the surface, warming the air we breathe. But with every rise and fall, the ocean cools, heals, renews itself. Even in the smallest flicker of plankton, there's a story of equilibrium, a reminder that even the unseen can hold the world together. The poetry of light. As we linger here, imagine the water around you slowly darkening. The last hints of sunlight fade to blue, then indigo, then black. But even in that fading, there's beauty. These are the seamounts and mid-ocean ridges, mountain ranges that stretch across the globe, hidden beneath kilometers of water. They are the planet's backbone, its living architecture, constantly shifting, growing, and reshaping itself. The longest mountain chain on Earth. If you could drain the oceans completely, you would see a continuous chain of mountains spanning more than 60,000 kilometers around the world. It's called the Mid-Ocean Ridge, and it winds like a scar through every ocean basin, from the Atlantic to the Pacific, from the Arctic to the Indian Ocean. It is, by far, the longest mountain range on Earth, and yet almost no one has ever seen it. Here, deep beneath the waves, the Earth's crust is being created. Magma rises from the mantle, cools in the freezing seawater, and forms new rock. Over millions of years, this slow but relentless process pushes continents apart, reshaping the face of the planet, where the Earth breathes. At the summit of these ridges, cracks form, narrow openings where molten rock seeps through. These cracks are the lungs of the Earth, releasing heat and gases into the deep. Through them, the planet breathes. Each exhalation brings minerals and energy that fuel entire ecosystems. Each inhalation pulls the ocean deeper into the crust, cooling and transforming the planet from within. When we think of Earth as alive, this is what we mean. The planet isn't static, it's dynamic, a slow-moving organism on a planetary scale. Mountains in the dark. Seamounts, underwater volcanoes that never reach the surface, rise thousands of meters from the ocean floor. Some are as tall as Mount Everest. Others are small, clustered together like undersea cities. Many are extinct volcanoes, their peaks worn smooth by the weight of water and time. But some are still active, occasionally erupting in silence, sending ash and minerals drifting upward like underwater smoke. Over time, coral and sponge colonies cover their slopes, turning them into havens of life. Scientists call seamounts oases of biodiversity. Though they cover less than 1% of the ocean floor, they host over 1/3 of all marine species. In the dark, mountains bloom. Ridges of fire, valleys of silence. Between these mountain peaks lie deep valleys, trenches and rifts that can stretch for thousands of kilometers. They form where tectonic plates pull apart or collide with unstoppable force. At these boundaries, the Earth's crust cracks open like a scar. Sometimes magma pours out, building new ridges. Sometimes one plate slides beneath another, sinking into the mantle and melting away. It's a slow dance of creation and destruction, the same process that has shaped our continents, our mountains, our islands. The ocean hides this drama beneath a calm surface, but beneath that calm lies a world of movement. the hidden volcanoes. We often think of volcanoes as violent, erupting with smoke and fire. But down here, eruptions are different. The pressure is so immense that explosions cannot form. Instead, molten rock oozes quietly from the seafloor, forming pillow-like shapes as it cools. Each flow adds another layer to the growing crust, building mountains in slow motion. Some of these volcanoes form islands: Hawaii, Iceland, the Azores, all born from fire rising through water. Every island is a reminder that what happens in the deep eventually reaches the surface. Mapping the invisible. Until recently, no one truly knew what the ocean floor looked like. For centuries, we imagined it as flat and featureless. Then came sonar, sound waves sent into the deep, bouncing back to reveal the contours of the unseen world. Today, satellites and autonomous drones can map vast stretches of the ocean floor. Each new survey adds detail: mountains, valleys, ridges, and plains slowly appearing on digital maps like constellations drawn in reverse. But even with all our technology, most of the seafloor remains unmapped. It's as if the Earth still holds its breath, refusing to reveal all its secrets at once. The energy of motion. Every mountain beneath the sea is a record of motion, of how continents drift, how oceans open and close, how the planet evolves. Tectonic plates move only a few centimeters a year, about the speed at which our fingernails grow. But over millions of years, those small shifts reshape everything. The Atlantic Ocean is still widening. The Pacific is slowly shrinking. And beneath it all, the mid-ocean ridges keep rising, forging new earth from fire and water. We are living on a world that is constantly remaking itself, the pulse of the planet. When we think of breathing, we imagine air, lungs expanding and contracting. But the Earth breathes through rock. It exhales heat through vents and fissures, inhales ocean water that seeps into its crust. This rhythm, slow and ancient, keeps the planet alive. Each volcanic eruption, each tremor deep below is part of that pulse. It reminds us that even in stillness, the Earth is never truly still. The ocean as memory. Every ridge, every mountain, every trench tells a story of time. Rocks at the bottom of the sea record the history of magnetic fields, climate shifts, and continental drift. They are the planet's memory, layers of time stacked in silence. When scientists study the ocean floor, they're reading the diary of the Earth. Each line written not in ink, but in stone and pressure. And though that story began billions of years ago, It's still being written right now in the darkness beneath the sea. In the next part, we'll dive into the deepest valleys of the ocean, where the pressure is unimaginable and light has never existed. These are the submarine canyons and abyssal trenches. Submarine canyons and abyssal trenches. We've climbed mountains beneath the sea. Now, it's time to descend again into the deepest valleys of our planet, far below the calm waves, past the ridges of fire and plains of silence, lie vast scars carved into the Earth's crust. They are deeper than any canyon on land, darker than any night sky, and older than the continents themselves. These are the submarine canyons and abyssal trenches, the deepest places on Earth. The hidden valleys beneath the waves. Most coastlines are not smooth beneath the surface. Instead, they plunge into steep ravines, underwater canyons carved by ancient rivers when sea levels were lower, and later deepened by ocean currents. The Monterey Canyon, off the coast of California, is one of the largest. It's deeper than the Grand Canyon, cutting more than 3,000 meters into the seafloor. Through these canyons flow underwater avalanches called turbidity currents, massive movements of sand, silt, and rock that shape the seabed in slow motion. Each current can carry more sediment than all the rivers on Earth combined. They are invisible giants, rearranging the planet one grain at a time. Deeper still, the abyssal trenches. But the true depths begin where the crust bends, where one tectonic plate slides beneath another. This process, called subduction, creates narrow, deep arcs in the ocean floor. These are the abyssal trenches, the deepest geological features on Earth. They form the boundaries between worlds, where continents end and the mantle begins. The most famous of them all lies in the western Pacific Ocean, the Mariana Trench. At its lowest point, the Challenger Deep, the seafloor plunges to nearly 11,000 meters below the surface. If Mount Everest were dropped here, its peak would still be hidden by more than a mile of water. The pressure of the impossible. Down there, pressure reaches 1,100 times the weight of the air above us. It's so great that even sound behaves differently, traveling faster, sharper, deeper. For decades, scientists believed that life couldn't exist in such crushing force, but they were wrong. Robotic explorers have filmed amphipods, worms, and even snailfish swimming calmly in these impossible depths. Their bodies are translucent, gelatinous, and perfectly adapted to survive in what seems unlivable. Every cell within them is a lesson in resilience, a blueprint for life under absolute pressure. Challenger Deep, the edge of exploration. In 1960, Jacques Piccard and Don Walsh became the first humans to reach the Challenger Deep aboard the Trieste. For nearly 5 hours, they descended through total darkness, listening to the creaks of their metal sphere as it resisted the weight of an entire ocean. When they reached the bottom, they saw the seafloor, a soft layer of sediment, and a single fish gliding across it. It was a moment that redefined human exploration. Half a century later, filmmaker James Cameron returned in a submersible of his own design, alone, descending once again into that alien silence. He described it as a place of eerie lunar beauty, utterly still, utterly indifferent. The sound of the trenches. Even here, sound is never absent. The ocean never sleeps. Hydrophones placed in the Mariana Trench have captured an entire symphony of the deep, the distant crackle of earthquakes, the rumble of volcanic activity, and the haunting songs of whales echoing down from miles above. It's a reminder that the ocean, though silent to our ears, is alive with unseen motion, a vibration that never stops. Life at the bottom. The organisms that inhabit these trenches are among the most extreme on Earth. Hadal snailfish live at depths beyond 8,000 meters. Their bodies are soft and flexible, their bones almost non-existent. Their enzymes are reinforced with special molecules that prevent their cells from collapsing under pressure. Around hydrothermal vents and subduction zones, microbes thrive in conditions that would destroy any surface life. They feed on methane and sulfur, turning poison into nourishment. It's almost as if life here has learned to write its own rules, as if the deep ocean were nature's laboratory for the impossible. Why these depths matter. Trenches may seem distant, but they shape the world above in countless ways. They act as graveyards for the ocean floor, pulling old crust down into the mantle and recycling it into new rock. They store vast amounts of carbon, helping to regulate Earth's temperature. When earthquakes strike, or when volcanic arcs rise, it's because of the movement that begins here, in the silent depths we can't see. In a very real sense, the fate of continents begins in the darkness of the trenches, the quiet frontier. Few places on Earth are as untouched. Each expedition to the deep trenches is a journey to a world no human has ever witnessed before. Even today, we've mapped only a fraction of them. Each descent reveals something new, a new species, a new sound, a new mystery. Beneath the ocean floor lies a world few people know exists. A hidden biosphere stretching kilometers below the surface. It's one of the largest, oldest, and most mysterious ecosystems on Earth. A world beneath the world. When scientists first began drilling into the seafloor in the 1990s, they expected to find nothing, just lifeless rock. Instead, they found something astonishing: microbes thriving deep beneath the sediment, alive in total darkness, cut off from sunlight for millions of years. These organisms don't rely on photosynthesis. They live on the faint chemical energy left behind by the slow decay of organic matter, or the minerals that seep from the planet's crust. In some places, they exist 4 kilometers beneath the seabed, where temperature and pressure would destroy most life. And yet, they survive, quietly, patiently, the deep biosphere. This hidden layer of life is known as the deep biosphere, a microbial world that stretches across the entire planet. It's estimated that up to 1/3 of all the Earth's biomass may live below the surface. Think about that for a moment. Every forest, every ocean, every creature on land, and yet a huge portion of life exists below it all, in the shadows of stone and time. These organisms grow incredibly slowly, dividing perhaps once every 100 years, but in that stillness, they endure. They are the keepers of life's persistence, proof that even in silence, life never truly stops. Microbes of the impossible. The microbes that live here are called extremophiles, lovers of extremes. Some feed on methane and iron. Others digest hydrogen or sulfur. They live at pressures that would crush steel and at temperatures approaching the boiling point of water. In places where oxygen has never reached, they breathe minerals instead. They exist in such isolation that some species may not have changed in millions of years, time travelers in microscopic form. Each discovery challenges what we thought we knew about the limits of biology. Every borehole drilled into the ocean floor is like opening a window into a world that has existed since before the dinosaurs. Life in the rocks. The most extraordinary revelation is not just that microbes live here, but where they live. They inhabit the tiny pores between grains of rock, the fractures in basalt, and the thin films of water that flow through sediment. They are microscopic tenants of a solid world, breathing, reproducing, communicating in a place that seems utterly still. To them, rock is not a prison, it's a home. The slowest lives on Earth. Time moves differently in the deep biosphere. Without sunlight or abundance, life slows to the bare minimum. Some microbes can take thousands of years to complete a single division. They exist in what scientists call metabolic stasis, alive but nearly frozen in time, and yet they persist. To them, centuries are seconds. They don't rush, they don't age, they simply exist, waiting for the rare moments when energy flows through their ancient world. In their patience lies an ancient wisdom that survival is not always about movement, but about endurance. Echoes of early Earth. Studying these organisms gives us a glimpse into Earth's earliest history. Before plants, before animals, before the sky was blue, life may have looked just like this: tiny cells feeding on minerals, thriving in the cracks of volcanic rock. The deep biosphere may be the living fossil record of our origins, a bridge between geology and biology, between planet and organism. And perhaps it's also a preview of what life could look like elsewhere, on Mars, beneath the ice of Europa, or in the hidden oceans of Enceladus. Wherever energy and water exists, life may follow, not in sunlight, but in the quiet heat of the dark. The breath beneath us. We tend to think of the ocean floor as the end of the world, but the truth is, it's only the surface of something deeper. Beneath every ridge and trench, beneath every grain of sand, the planet breathes, slowly, invisibly. Each microbe plays its part in recycling carbon, storing elements, and stabilizing Earth's chemistry. Together, they form a hidden heartbeat, a living network that keeps the surface world alive. It's humbling to think that every step we take on land, every wave that breaks on the shore, rests on a foundation of life we cannot see. A quiet revelation. The discovery of the deep biosphere reminds us that life is not fragile, it's unstoppable. It finds a way not just in sunlight and warmth, but in cold, pressure, and stone. It teaches us that the boundaries of possibility are wider than we ever imagined, and it reminds us of something deeply human, that sometimes the most important things are the ones we'll never see. In the next part, we'll leave science for a moment and drift into legend, exploring the stories of lost cities and sunken continents, where myth meets geology beneath the waves. This is Lost Cities and Sunken Continents. Lost Cities and Sunken Continents. For as long as we've gazed at the ocean, we've imagined what might lie beneath it, not just creatures or mountains, but civilizations, stories of lost cities, of worlds swallowed by the sea, echo through nearly every culture on Earth. And while myth gave us tales of Atlantis, Mu, and Lemuria, science has shown us something even more profound, that the ocean does, in fact, hold the ruins of our past. The legend of Atlantis. The story begins with Plato over 2,000 years ago. He wrote of a powerful island nation beyond the Pillars of Hercules, a land rich with knowledge, art, and technology. But its pride led to its fall. In a single day and night of misfortune, he said, Atlantis sank into the sea and vanished. For centuries, explorers searched for it. Was it in the Atlantic, the Mediterranean, the Caribbean? No one knew. But the idea endured that an entire civilization could disappear beneath the waves. Modern science doesn't confirm Plato's tale, but it does reveal how seas can swallow entire worlds. Rising sea levels, earthquakes, and volcanic eruptions have erased coastlines and reshaped continents countless times. It's over 5,000 years old, making it the oldest known underwater city in the world. And off the coast of Japan, near the island of Yonaguni, a mysterious set of stone terraces rises from the seafloor. Some believe they're natural formations. Others insist they're man-made, the remnants of a forgotten civilization. Science hasn't decided, but mystery endures. Continents that disappeared. Beyond cities, there are whispers of lost continents, vast lands that once connected worlds. Doggerland, for example, once joined Britain to mainland Europe. It was a lush, green plain filled with rivers and animals, home to human settlements. But as the last ice age ended, melting glaciers raised sea levels, and the North Sea swallowed it whole. Fishermen still pull ancient bones and tools from those waters, echoes of a world that once was. There's also Zealandia, a nearly submerged continent east of Australia. Most of it lies under the Pacific, but parts, like New Zealand, remain above the waves. Scientists now recognize it as Earth's 8th continent, a reminder that our maps are not as final as we think. The power of the sea. The ocean is not just water. It's motion, transformation, memory. Over millions of years, it has buried mountains, reshaped coastlines, and rewritten the geography of life. Every rise and fall of sea level has left traces of human history scattered across the seafloor. Villages, temples, forests, and rivers, all sealed beneath sediment and time. When we speak of lost cities, we are also speaking of change, the slow, endless conversation between land and sea, myth and memory. What's fascinating is how memory survives. Across cultures, stories of great floods persist, from Mesopotamia to India, from the Bible's Noah to the Aztec god Tlaloc. Perhaps these myths are not pure imagination, but memories, ancient echoes of real disasters, passed down through generations until they became legend. Every myth carries a seed of truth, and in that truth, we find the shared fear and awe of a planet in motion. Science meets imagination. Today, sonar, satellite imaging, and deep-sea drones allow us to peer into these drowned worlds. We can map ancient riverbeds, trace the outlines of cities, and even recover artifacts untouched by air for millennia. Each discovery bridges science and story, proving that imagination often leads the way. Because before we find, we must first believe that something is there to be found. The meaning of what's lost. Why are we so drawn to lost cities? Perhaps because they mirror us, our fragility, our ambition, our impermanence. They remind us that all things change, that even the strongest civilizations can vanish, and that what endures is not stone or power, but curiosity. As long as we keep searching, Atlantis still lives, not as a place, but as an idea, the eternal desire to understand what lies beneath. In the next part, we'll return from myth to science, exploring how these underwater worlds are mapped, measured, and brought back to light through modern technology. This is Mapping the Hidden Ocean. Mapping the Hidden Ocean. For most of human history, the ocean floor was pure imagination. Sailors guessed at its shape. Cartographers drew it as blank space, a void beneath the waves. Today, that void is beginning to take form. We are mapping the unknown, not with ink and parchment, but with sound, light, and code. And in doing so, we are revealing an entire world that was hidden in plain sight. Why mapping the ocean matters. We've mapped the surface of Mars more precisely than we've mapped our own planet's seafloor. Over 80% of the ocean remains unmapped, unobserved, and unexplored, and yet it covers more than 2/3 of Earth. Without maps, we can't truly understand how the ocean works, how currents move, how life spreads, how our planet breathes. Mapping the ocean isn't just exploration, it's survival. The invention of sound. In the early 20th century, scientists realized that sound travels faster and farther in water than light. By sending out pulses of sound and measuring how long they took to return, they could calculate distance. This was the birth of sonar, sound navigation and ranging. At first, it was used to detect submarines during wartime, but soon its power for discovery became clear. Every ping was a question, every echo an answer. Piece by piece, the contours of the ocean floor began to emerge. Echoes of the deep. Modern sonar systems send thousands of sound beams at once, a method called multi-beam sonar. Each beam reflects off the seafloor at a different angle, creating a mosaic of echoes. When combined, they form a three-dimensional image of the seabed, its mountains, valleys, and plains. What once was a flat blue void now reveals texture, form, and history. Every ridge is a memory of fire, every trench a record of motion, and all of it written in echoes. Drones beneath the waves. Today, the task of mapping has passed to fleets of autonomous underwater vehicles, drones that can dive miles deep and roam for weeks at a time. They move in silence, following digital paths through the dark, collecting millions of data points. Some are no larger than a dolphin. Others, like the Hugin or Bodie McBoatface, can cover entire ocean basins on a single mission. Their sensors capture not just topography, but sound, temperature, and chemical composition, painting a living portrait of the sea. Satellites from above. While sonar listens from below, satellites see from above. They can't look through the water directly, but they can measure tiny changes in sea level, ripples so small they reveal the shape of mountains and trenches beneath. A seamount's gravity pulls the water slightly higher. A trench pulls it lower. By reading these subtle patterns, satellites can infer what lies below, turning invisible gravity into visible maps. It's like seeing the shadow of a landscape reflected on the ocean's skin. Artificial intelligence and the ocean map. With so much data flowing in, human hands alone can't keep up. That's where artificial intelligence steps in. AI systems now analyze sonar and satellite readings, detect patterns, and even predict where unmapped features might lie. They can distinguish coral reefs from rock, volcanic ridges from sediment plains, and identify new ecosystems hidden in plain data. Every day, the digital ocean becomes clearer, a vast, evolving mirror of the real one. The Seabed 2030 Project. In 2017, the Seabed 2030 Project was launched, a global mission to map the entire ocean floor by the year 2030. It's a collaboration of countries, researchers, and explorers around the world, sharing sonar data, satellite imagery, and AI models. Each map they complete is a step toward understanding our planet's final frontier. Already, millions of square kilometers have been charted for the first time. The results are astonishing. Mountain ranges taller than the Alps, volcanoes where no one expected them, and deep trenches that reshape our view of Earth. The challenge of scale. And yet, the task is enormous. The ocean is vast and its depths are hostile. Storms, pressure, and darkness make exploration slow and costly. Even our best drones can only map a few hundred square kilometers per day. At this rate, it will take decades to complete the picture. But perhaps that's part of the beauty, that discovery still takes patience, even in an age of instant knowledge. The future of exploration. Soon, fleets of autonomous drones will operate together like schools of fish, communicating wirelessly, sharing data in real time, mapping the seafloor continuously. New AI systems will stitch their findings together into high-resolution, real-time maps of the underwater world. We'll be able to watch as volcanoes form, as trenches shift, as life expands into newly discovered realms. The ocean will no longer be a mystery, but a living, breathing landscape we can finally see. The beauty of the unknown. And yet, even when we've mapped every ridge and trench, the ocean will still hold secrets, because mapping can reveal shape, but not soul. It can show where the mountains rise, but not what it feels like to drift among them. It can draw the borders of discovery, but not the wonder that drives it. In every echo, in every pixel, there will still be mystery, and that, perhaps, is what keeps us exploring. In the next part, we'll explore the forces that shape the ocean itself, the waves, the tides, and the invisible energy that moves the world. This is the rhythm of the sea. The rhythm of the sea. If you listen closely, not with your ears, but with your heart, you can feel it. A slow, steady pulse that never stops. The ocean moves to a rhythm older than life itself. It rises and falls. It breathes in and out. It turns the planet like a wheel. The hidden power of currents. While the tides move up and down, ocean currents move across the world, rivers within the sea itself. They carry heat from the equator to the poles, nutrients from the deep to the surface, and life from one continent to another. Some, like the Gulf Stream, are warm, powerful highways of energy that shape the climate of entire regions. Without them, Europe would freeze, rainfall patterns would collapse, the planet's balance would crumble. Currents are not just motion, they are memory, circling endlessly, passing energy from generation to generation of waves. The dance of wind and water. Winds sculpt the sea. They draw waves across the surface, each gust transferring a small fragment of energy. Over time, these fragments combine. Ripples grow into swells, swells into waves that travel thousands of kilometers. When those waves reach the shore, they break, returning their energy to the air and land. It's a perfect cycle. Wind to wave, wave to coast, coast to sky again. Even in chaos, there is rhythm. The deep currents, the ocean conveyor. Far below the surface, another movement flows, slower, colder, deeper. This is the global ocean conveyor belt, a continuous current that connects every sea on Earth. It begins in the North Atlantic, where icy water sinks into the abyss. There, it flows south, circling the Antarctic, then rising again near the Pacific and Indian Oceans. A single loop can take 1,000 years to complete. It is the planet's circulatory system, carrying oxygen, carbon, and nutrients through every layer of the ocean. Without it, the deep would stagnate. Life as we know it would fade. The ocean doesn't just move water, it moves life. The moon's silent command. Every wave, every tide answers to the moon. It may be small, but its gravity pulls an entire planet's worth of water. And because the oceans move, so do we. Our weather, our coastlines, even our time. In some sense, the moon choreographs the Earth's breath. When you stand by the sea and watch the water rise, you're witnessing that pull, the invisible tether that connects worlds. It's a reminder that nothing exists alone. Even the quietest wave is part of something vast and cosmic. Storm and stillness. Of course, the sea is not always calm. Sometimes its rhythm quickens, winds rise, currents twist, the ocean becomes a storm. But even then, it follows the same invisible laws, the same patterns of heat, gravity, and spin. Every storm is energy redistributing itself. Every calm is recovery. Balance is never broken, only reshaped. The rhythm continues. The sea and the mind. Perhaps that's why humans find peace by the ocean. Our hearts, too, beat in waves. Our breath moves in tides, in and out, rising and falling. When we listen to the sea, we're hearing a reflection of ourselves, our own biology written in water. Maybe that's why the sound of waves soothes us. Because it reminds us, deep down, that we are part of something larger, something that moves, that endures, that never truly ends. The eternal pulse. Every tide is a breath, every current a thought, every wave a heartbeat. The ocean is not just a place, it's a process, a living rhythm that sustains the planet. And though we may chart its surface, record its sounds, and name its storms, the sea doesn't need our understanding to exist. It simply continues, rising, falling, forever whispering its ancient song to those who are still enough to hear it. In the next and final part, we'll return to the surface to reflect on everything the deep ocean has taught us about life, time, and the fragile beauty of our world. This is the ocean within. The ocean within. The journey is almost over. We have drifted through sunlight and shadow, across mountains and canyons, past creatures that glow in the dark, and into worlds that no human eye has seen. Now, as we rise slowly toward the surface, the water around us lightens, and everything we've witnessed begins to settle, like sand in still water. The ocean has told its story, but perhaps it was never just about the ocean. Perhaps it was about us, the mirror of the deep. When we look into the sea, we are really looking into a mirror. Its surface reflects the sky, calm one moment, storm-torn the next. Its depths reflect something deeper still, the unseen world within ourselves. There are parts of our minds as vast and hidden as the trenches, as luminous as bioluminescent creatures, as steady as the tides, and just like the ocean, we hold light and shadow in equal measure. Every emotion is a current, every thought a wave, every dream a deep sea shimmer that rises, then fades. Depth as meaning. We live most of our lives near the surface, busy, bright, visible, but meaning often hides in the deep, in silence, in reflection. Just as the ocean conceals mountains, our own depths conceal things long forgotten, memories, instincts, and quiet truths that shape us without words. To explore the ocean is to explore the human condition, to understand that beauty and darkness can coexist peacefully in the same vast space. The rhythm of existence. Every wave is born, travels, and breaks, and then another follows. It's endless, and yet never the same. So too are we. Every moment of life rises, peaks, and dissolves, a rhythm that mirrors the tides. We are made of water. We are made of movement. The same chemistry that drives the ocean flows within our veins. When the sea breathes, so does the world, and so do we. Silence as the final frontier. The deepest parts of the ocean are not filled with noise or color. They are still, weightless, timeless. Silence down there is not emptiness. It is fullness. It holds potential, possibility, and the quiet hum of existence itself. In that stillness, we are reminded that peace doesn't come from the absence of motion, but from understanding it. What the ocean teaches. The sea teaches patience, that change is slow but unstoppable. It teaches humility, that no matter how far we explore, we will always be standing on the edge of the unknown. And it teaches connection, that everything, everywhere, is part of a single rhythm. A droplet of rain, a crashing wave, a heartbeat, all parts of the same eternal song. The ocean of the mind. Scientists often speak of the brain as an ocean of neural waves, billions of signals moving in harmony, creating thought, emotion, and awareness. When we dream, our minds drift below the surface into their own twilight zone. Images rise and fall like tides, memories swirl like plankton, and consciousness floats, half asleep, half awake. It's the same balance the sea holds between chaos and calm, light and dark, surface and depth. To know the ocean is to know ourselves. The return to light. As we ascend, the blue begins to brighten, shadows dissolve. The surface shimmers above, a window between two worlds. Breaking through it feels like waking from a dream, but that dream remains within us, a quiet awareness that the world is far deeper and far gentler than we ever imagined. When you stand on the shore again, listen carefully. The glowing creatures, the drifting currents, the silent trenches beneath the stars. Remember that within you flows the same water that fills the seas, the same salt, the same energy, the same ancient story. You are not separate from the ocean. You are made of it. So breathe deeply. Let your mind drift and feel the calm tide rising within. You are floating in the vastness of yourself. You are the ocean within. Thank you for joining this journey through the deep. May the rhythm of the sea bring you peace, and may curiosity always carry you to new horizons. Until next time, sleep well and dream in blue.